Through this recording, I want to cover some of the concepts covered in Chapter 2 of your textbook on elementary programming. Essentially, what we're going to learn is how to write Java code that uses input from the user. We do some processing and we'll create output from our program. We also talk about variables and assignments and expressions. So let's go ahead and look at this example called compute_area.java. So if you look here, notice that we've learned, as you learned before, is that you want to save your file using this public class definition. And remember that the name of the class must match the name of the file. So in this case, the class name is compute area, and the name of the file is compute_area.java. So notice here we have our main method that we've already talked about in Chapter 1. Notice we have two variable definition, radius and area. We'll just talk about variable definitions shortly. Radius equals to 20 makes an assignment. So essentially all we're saying is that 20 is assigned to the value of this variable radius. This is an expression where we say area equals radius times 3.14. So we're just computing the area of a circle in this case, and then we print the area. So remember that in order to compile this, we'll go to external tools and compile the Java program. And while this thing is compiling, again, remember that, or I guess we'll talk about the fact that radius and area are variables. Variables are essentially placeholders for values. This equal statement is referred to as the assignment statement, and you can have as many assignment statements as you want in a program. This here is an expression where we compute a product, or in this case, we're multiplying three things together, and we're making the assignment to this variable. And system.out.println is Java's way of printing the values of variables. Anything inside the pair of quotations will be literally printed on the screen. So in this case, we will say it will print the area for the circle of radius, followed by, we use the plus symbol to concatenate strings, or a string or sequence of characters, plus the value of radius. So in this case, it will be 20. The word is, and then followed by the calculated value of area. So the very first time the Java program compiles, it may take a while just because of all the libraries that have to be used in order to compile this program. So while the program is compiling, let's go back and talk about some of these. So you see how the program is traced. We assign value to radius and area. So in memory, we have two variables that have no values yet. We haven't initialized them to anything. Area radius equals to 20, makes the assignment. Area equals to radius, makes another assignment. So area is now 1256. And then this will just display the value of that variable. So this program compiled. Now if I go ahead and run this thing, I'll just do run Java application, and notice it says the area for the circle is 1256.636. Now we'll talk about formatting our output actually in Chapter 4, I believe, and we also have another example that we could use to format numbers to a certain number of digits after the decimal point. So for now, you don't really have to worry about the number of digits after the decimal points. Okay, so if I go back, console input, essentially we use this declaration or definition. We use a class called scanner, followed by any variable name. in this case input, and then new scanner system.in. Now, all of this will begin to make sense a little bit more when we talk about object-oriented programming. But right now, you just have to take my word for it that this is how we do input in Java. Create a variable, and then with this variable or this object, we could actually use various methods that allow us to perform actions. So in this case, you'll notice when I say double D, we just define D to be a double to hold any value, equals input, which is this variable name, dot next double. By the way, Java is case sensitive, so if you use next double with a lowercase d, or if you misspell it, you will get a compiler error. We'll give you an example of how to actually use this. Now, identifiers essentially are a sequence of characters that consist of letters, digits, underscores, and dollar signs. In Java, an identifier might start with a letter, an underscore, or a dollar sign. It just can't start with a digit. You can't have spaces. They can't be reserved words, but identifiers can be of any length. So a variable or an identifier, essentially, you'll notice radius is a correct variable name because it starts with a letter. Essentially, anything that starts with a letter works as a variable. And by convention, all your variable names should be lowercase. So just make sure that you'll follow this convention that variable names must start with a lowercase letter. So when we declare variables, essentially all we're saying is in this statement where we have int is a primitive data type that defines an integer. So all we're saying is that x can hold any whole number. Double radius, we're saying radius can hold any number, whether it's whole number or has decimal points. Char a tells the compiler that we're creating a variable named a that could hold a single character. Again, we'll talk about all these different data types that Java allows us to use. So assignment statement, we use the assignment operator. So x equals to 1 is assigns 1 to x. Notice variables always go on the left and values go on the right. By the way, this is also called a assignment expression because it involves essentially assigning a value to a variable. Now, the only thing, of course, you may have guessed by now is that when you say int x, x can only hold a whole number. So when you say x equals to 1, that's okay. But if you say x equals to 1.5, that is not okay because the type of the variable and the type of value must match. Remember that we defined a as a character, so a can only hold a single character inside a pair of single quotes. So you can also declare initialize in one step. Int x equals to 1 is exactly the same as saying int x with a semicolon and then x equals to 1 at a different statement. And this is also okay to do. If you add the word final before your definition, then all you're creating is a named constant, meaning that if you define your variables like this, you cannot change the value of the variable after this. So this is a kind of a nice way to protect yourself against yourself by making sure that named constants are not changed through your code. So a company name or a tax rate or the number of students in a class, they might be good candidates for named constants. Naming conventions, choose meaningful and descriptive names. Avoid using variable names like ABC or capital or anything that starts with a capital letter. We also use this camel case methodology to essentially name our variables. So if they're created using multiple words, again, start with the lowercase and then just create or start with a uppercase letter for every subsequent word. Don't make these things names too long and also don't make them too short. So again, you can read up about this in your book also. So numerical data types. Java allows for data types such as byte, short, int, long, float, and double. And the only difference really between these data types is the size of the values that they can hold. So if you're really working with huge numbers, you may want to consider using double. But if you're using smaller or smaller numbers, you could use byte. And you can use you look at your textbook to kind of. It's a good idea to kind of know the relative size of these data types. In this class, for whole numbers, we usually use int, and for any other number, we use double. Now, when you read numbers from the keyboard, no, we already saw an example using next double. Well, if you're reading a float, you use next float. If you're using an int, you use next int. Again, by far the biggest mistake is students misspelling these method names. So again, ask yourself what is really happening when Java executes this statement. Input next int will wait for you to input a whole number. Whatever you input at the keyboard, when you press the enter key, that value goes into this variable value. So instead of me saying value equals 50, I can actually ask the user to input the value. So with this example, we said radius equals to 20. Well, instead of radius equals to 20, I can actually ask the user to input a value for radius. We'll get a couple examples of that in a few minutes. Numeric operators that Java uses, the common ones are addition, subtraction, multiplication, division, and remainder is something that you may have not seen. The percent operator or the modulus operator essentially returns the remainder of division of two numbers. So notice 20% 3 is equal to 2, because if I take 20 and divide it by 3, I'm going to get six threes. I can't have 7 because 7 times 3 will be more than this number. So 20 divided by 3 is 6, and then 6 times 3 is 18. 20 minus 18 is 2. Remember, it gives you a remainder of dividing two numbers. This has a lot of usage, especially when we get to algorithms that can benefit from it. So keep this in mind, and we will get to more examples of how this could be used. So integer division, if you divide two integers, you always get another integer. So 5 divided by 2 is not 2.5, it's actually 2. All right, so I want to kind of hurry up through this. So again, make sure you read through these. Some notes, when you do 1 minus 0.1 minus 0.1, you expect to get 0.5, but you may actually get something like this. That's because whole decimal numbers are converted to, well, all numbers are converted to binary, and binary arithmetic or binary conversion with decimal numbers are not accurate. So you'll get to some of these pitfalls when you're dealing with doubles, which we probably won't talk too much about, but it's good to know that if you did something like this and you got some weird number like that, it's because of double to binary conversion. If these were actually whole numbers, like 1, 2, and 3, and 4, then you will get an accurate value. So math.pow, 2 and 3, it just tells you that there is a method called POW that takes 2 to the power of 3. We'll talk about this math class later in the course, but right now, if you wanted to use some of the predefined mathematical functions, we have to use this math class. Number literals, I'm going to go ahead and kind of go through these. Double versus float. Double gives you 16 digits after the decimal point. Float only gives you 7 digits. So if you're doing really, really accurate calculations, you may want to go ahead and use essentially double values. Scientific notation, we use the letter E for scientific notation. 1.23E2 is really the same as 1.23 times 10 squared, which is 100, so it would be 123.456. Arithmetic expressions, you may have seen these in your math classes. Of course, if you want to convert this into Java, you kind of have to write everything longhand on one line. So we always have to, so for example, 10 open print y minus 5, that's really 10 times, so that's why you have to use an asterisk. And of course, if you want to make sure that expressions are performed in the correct order, you'll have to use parentheses. Because otherwise, for example, 10 times y minus 5 without this parentheses will actually multiply 10 by y and then subtract it from 5, which is not what you want. In order to evaluate expressions, you always do parentheses first, and then multiplication, division, and modulus have the highest priority, and then addition, and then subtraction. Although addition and subtraction and multiplication, division are all on the same level. Fahrenheit to Celsius conversion. Let me see if I have this in my examples. No, I don't, but it's a good idea if you get a hold of this. By the way, all of these files are available to you from the author's website. If you can't find these things, you have to let me know. Okay, now we also have augmented assignment operators, which kind of combine two statements into one. You're not really required to use these, but you have to know how they're used. So plus equal, so when you say I plus equal 8, all you're saying is you're saying I equals I plus 8. Well, these two are exactly the same, so I actually prefer I equals I plus 8 rather than this. But if you wanted to do so, is always the operator followed by the equal sign. We have two operators for decrement and increment by 1. Plus variable, it adds 1 to this variable, and var plus plus will do the same. So whether you do a pre or a post as a standalone statement, it doesn't matter. They do the same thing. Same thing with minus minus and as a pre or a post. The only time they make a difference is that when you use them in your expressions. So if you say j equals plus plus I, notice what it does. It actually increments I by 1 and then puts it in j. Here when you say int equals to j equals I plus plus, it actually makes j equals to the value of I and then increments I. So read your book about this if you're not sure about this process, but it's pretty straightforward. It just depends on whether you're using a pre or a post in an assignment. Again, you don't have to do these things because these augmented operators aren't very descriptive. All right. So numeric type conversion, just remember these rules. Essentially that if one of the operands is double, the other is automatically converted to a double. If one of the operands is float, the other one is float, long, and then if nothing else, then everything is converted to an integer. So you'll notice here it says double D equals I times 3.1. Well, because this 3.1 is a double, this is also converted to a double before doing the multiplication. So essentially what's happening is that the higher values or higher variables in the order of numbers that they can hold have higher priority. So I think notice byte has the lowest priority and double has the highest priority. Again, in this class, we usually deal with doubles and ints. Now, when you say double D equals to 3, what Java does is actually puts D equal to 3.0, essentially widens the type. We could also narrow it using what is called typecasting. So int of 3.0 is just 3. Int of 3.9 is just 3. Notice that when we do a typecast, we don't actually round numbers, we just truncate the numbers. So int of x equals to 5 divided by 2.0. Well, what do you think is going to happen here? Remember, we're going to do this first. So 5 divided by 2.0, because this is double, this is also converted to a double. So 5.0 divided by 2.0 will be 2.5. And then when you convert it to an x, which is an integer, that would x becomes just 2 and not 2.5. So when you're writing code and you see that digits after the decimal point are truncated, that's the problem. Keeping 2 digits after decimal points, this is a good example if you want to use this. And by the way, this is an example that uses the scanner class, which I was going to use anyways. You'll notice here is that we're calculating tax, and then we're using this little simple formula to convert the value to 2 digits after the decimal point. By the way, if you wanted 3 digits, all you have to do is multiply by 1,000 and divide it by 1,000. So let's see how this works. Let's say the tax is actually equal to 8.3295. So what the program does, it says, well, take that and multiply it by 100. What do you get when you multiply this by 100? You're going to get 832. Oops, I'm going to keep that. 832.95. I hope you all agree with me that that's what you get. You just multiply the number by 100. Okay? Now it says convert it to an integer. Well, converting by an integer means you're going to chop off all of that digits. So what do you have now? You have 832. Now you take the 832 and divide it by 100, which you might have guessed would be 8.32. Notice we only now have 2 digits after the decimal point. Originally the number was this, they have 4 digits, but the output is always 2 digits after the decimal point. So I'm going to go ahead and comment this line out. Let's go ahead and compile this. Notice this ran compiled a lot faster. So when I run this thing, it's going to ask me. Now remember, the reason it's asking me for a purchase amount, because I'm using the scanner object input in this case, and I'm using the next double. So if I put in, let's say the purchase amount was $12.89. When I press enter, it says your tax is 0.77. Okay, so that essentially converted 2 digits after the decimal point. Now, since I have here, let's also go ahead and ask the user to, I don't know, let's say I want to ask the user for enter your age. I don't know why, but let's ask the user for their age. Now, age is going to be a whole number, so I'm going to do age equals next int. And then I'm going to say, I'm going to tell the user how old they are. System.println you are plus age plus, I need a plus sign, years old. Okay? Now, if I compile this code, I'm going to get a compiler error, and I hope you realize by now what the compiler error is. So, because age is defined as a double, but I'm using a next int because I'm using an integer instead of a double. So let's see if we get, as a matter of fact, it did not give me a compiler error, which is okay. Let's see, I'm going to run it. So for enter age, I'm going to get 12, and it says you are 12.0 years old. So it read it, but then read it as an integer, and then converted to a double, which is perfectly fine. Purchase amount $12, and that's our tax. I'm going to run it again, and this time for age, I'm going to say 12.89. Notice now I get an error message because 12.89 is not a valid valid integer, and you get this error. By the way, in about 8 or 9 weeks, we'll learn how to handle these types of errors. So ideally, what I had to do was use age as an integer, That way everything is consistent. So now if I say 12, it'll say 12 years old and not 12.0 years old. Okay? So this example, sales tax, which I will provide as a part of this, well, actually, you can actually, it's in your student resources. You can actually take a look. It shows you essentially how to read data or read input from the keyboard. Now, when you cast in an augmented expression, something like, remember we said plus equal to or asterisk equal to, whatever, the way Java performs these actions is that it will actually perform the operation and then typecast it to whatever the proper type is going to be. So we said sum is an integer. So when you say sum plus equal 4.5, you actually get 4, because what Java is going to do is going to take the 4.5, adds it to 0, and then casts it to an integer because you said that you want an integer. So you got to be very careful when you use your augmented expressions. Now, software development process, essentially, if you want to write computer programs, you always must start with requirements. Well, essentially, a lot of times you're writing code for people, for clients. Hopefully you're getting paid for that. And you'll have to ask your client or your user, what is their requirements? So requirement specification essentially is understanding what the user wants to do. So if a user wants you to write a program to convert currency for them, well, you have to understand that what currencies they want to convert, because unless you want to do all of them, which is fine, and what sort of input you expect your users to provide. System analysis, essentially we'll have to break down the problem into smaller manageable pieces. And then we design our code. Usually what we do is we write a flowchart or a pseudocode, and essentially we'll create a higher level hierarchy of the processes that we want to code for. This is often referred to as the IPO cycle, because we get input, we do some processing, and then we obviously want to output maybe reports or files or whatever the user wants. Implementation essentially means that you're going to write the code. Maybe in this class you're going to write the actual code in Java. You're going to have other people, or yourself in this case, test your code, making sure that the code runs, behaves the way it's supposed to. Then you deploy it. Essentially, you send it to people so they can install it on their desktops, or they can run it from a website, and then have essentially deployment means the users can now use it. And of course, you want to continually maintain it by creating patches and code fixes as errors happen. Of course, no code is ever error-free, so that's why you have this complete process in your software development lifecycle. So these slides that, again, you have access to in Canvas kind of walk you through these processes. I'm not going to read them all for you. Computing loan payment, again, compute-loan.java is just a pretty good example of if you ever have taken out a loan, you can write a program to calculate your monthly payment. So the program is already available. As you might have guessed, you say, well, if I want to find monthly payments for a loan, I need to know the amount of the loan. I need to know the interest rate. And that's it. Because if you give me the interest rate, and also need to know the number of years, essentially the term of the loan. If you give me these 3 pieces of input, I can code this expression in Java and then give you your monthly payment. So that's what we do by trying to make sure that we understand the requirements of the program, and then what is going to be input, what is our processing, and what it is most likely in this case, just a monthly payment to produce as output. Monetary units is another one. Common errors and pitfalls. Let's walk through some of these. Notice it says double interest rate equals 0.05. I don't see a problem with that. But then you have double interest equals interest rate times 45. Notice we just misspelled interest rate. Java will crash, the compiler will crash on this line telling you that interest rate has not been defined. In Java, you have to define every variable and assign a value to every variable before you first use it. Here's another error. Int value equals 2 billion and some. You add 1 to it, you're actually going to commit an integer overflow. And what Java does is just give you a, it'll go to the other side and will give you a negative number like that. Now, some languages, when you do an integer overflow, will give you an error messages or will give you weird values. So remember that every data type has a limit on how big or how small the number could become on the negative side. Round off errors, we talked about this, just be careful. Anytime you perform numerical operations on double data types, you're bound to have round off errors. Unintended integer division. Notice you have two numbers, 1 and 2, and you say double average, which is good because you want the average to be a decimal number. Notice what happens here. 1 plus 2 is 3, both integers. 3 divided by 2 is going to be 1. It'll actually be 1.5, but you truncate the 0.5. So when this prints average, it will print 1.0 for you. But if you divide by 2.0 or explicitly cast this with open parentheses, double close parentheses, then you get the correct average, which is 1.5. So be careful about these common errors. Redundant input objects. I have scanner input, new scanner system in, and then we have input 1 system in. As you saw with this example, I'm asking for age, I'm asking for purchase amount. There is no need to create multiple scanner objects. All you need is 1 per method or 1 per program, really, in this case. So avoid defining multiple objects. The program will still work. It's just not a good idea to do so. The next, and that's it. I think time-wise, I usually want to keep these within about 30 minutes. So I hope you enjoyed this recording. Let me know of any questions. Goodbye for now.